The mic is yours.
Hello. Let me familiarize with the system, entertainment system. Yeah, okay. So this is Paolo Lucente from NTT Communications and pmacct. And I would like to tell you something about Bgp monitoring. And so there is nowadays a protocol called Bgp Monitoring Protocol. So I would like to share with you what is happening with Bgp monitoring, what are the latest at ITF. Of course, if you know ITF, there is always a lot going on over there. And yeah, that will be the focus of the presentation. So a bit of myself, it will be very quick. So I am Paolo Lucente. You can find me on GitHub. You can find me on LinkedIn, on Twitter. I am the author of pmacct, which is, among the other things, also a BMP collector. And I work currently in NTT, and I was before at Cisco, and I've been largely on the both service provider side and the vendor side. And it's I have been doing monitoring, especially in the area of flows, so NetFlow, SFlow, and things like that for a long time. And of course, I bring also interest in every other sort of data collection. So that is why BGP and BMP now. But there is also streaming telemetry, for example, that interests me, even though it's out of the scope for this presentation. And I've been doing that for long enough, and I know that the statement on this slide, will cause that when we speak one-to-one, you will be watching here instead of my eyes. So that's nice. So let's start with a recap about BGP before speaking BMP. BGP is it's a super quick summary. So it's a protocol to advertise reachability information. We are used to say NLRI, so network layer information. But the network layer part, it's a little bit outdated in the sense that it's true that BGP was conceived for that, but nowadays it's used as a generic transport for every sort of information. And if you are up to date with your Facebook feed, you have seen maybe that there was this playing battlefield over BGP from a few weeks back. So yeah, you can do plenty of stuff with BGP. It's a very good protocol at policy control. So you can whoever has a network engineering background can remember the whole BGP selection algorithm, when the local preference kick in, when the LIS pathland kicks in, and things like that. But the reality is that nowadays, content providers, they are running, SDN systems, and then more and more, instead of the BGP selection control, you use things like jitter, latency, packet loss as measures. So in the end, BGP is just not to brute force routing, so just to know that a route is available through a peer. But then if I have that route available through multiple peers, then it's these quality characteristics that drive how the content is delivered rather than BGP. And then it's superlative at information hiding. It's really the best. I mean, at having information and not being able to dig out of the protocol, out of the RIB. But then again, I mean, that was a feature, actually, information hiding. It's a feature of BGP because it's the way to scale to, RIBs with millions of entries and things like that. And so the information hiding, it's actually a very good, segue for the rest and for BGP monitoring as well. So as I was saying, I have been, trying to dig information out of BGP. So more than on the routing part of BGP, I was involved with the monitoring part of BGP for quite a long time. And together with Elisa, when Elisa was at Netflix, and I was representing, pmacct, so this BGP collector, NetFlow collector, and things like that. So we presented at NANOG roughly in 2013 about our first attempts, at gaining visibility into BGP. So Netflix, as you can imagine, they have a lot of paths for every prefix, and they do that for balancing the load of the network, right? And because they have a lot of traffic. And back then in 2013, BMP was not an RFC yet, and of course, not to mention there were no real implementation on the vendors and things like that. So we were kind of blind, and the only thing we could do back then was to start establishing BGP with add path sessions to the root collector, to pmacct, to try to have visibility not only in the main path, but in the backup paths. So not only all, of course, there was never only one active path. The active path were several, and then there were several backups and things like that. And the problem with AddPath, there were a few problems with AddPath. So first is that it was still part of the BGP stack, right? So it's still a complexity that you are putting that you are enabling in your BGP stack, and it would be very nice to have a segregation between the monitoring part and the actual routing one. So if you think about it, because of a monitoring system wants to see routing information, you are making your, enabling a feature that actually your network doesn't really need, right? And so that was, really an architectural, conceptual, philosophical kind of problem. And then also the problem conveyed by AddPath was also that you have always to specify, how many paths you want to convey, right? So you have to say 4, 8, 12, and the more you do, the more memory this thing consumes. And of course, when the problem is unbound, like I don't know how many paths there are, so I cannot tell you I want 4 or I want 8. I want all the paths that they are there, how many they are, right? And so it was difficult to configure so maybe this was more an implementation issue, but we faced that as well. So, it was difficult, and we were totally looking forward actually to BMP back then. So coming to BMP is a BGP monitoring protocol, and let me give you a little bit of history about BMP. So it's that RFC 7854, and it was awarded in 2016. But BMP started in 2008, actually, right? So between 2008 and 2016, it's quite a ride. And there was some work going on until 2012, then there was a stall, and then there was traction again, and then, this thing was just standardized between, with not that many addition to what was, done originally with additions, but still with the original concept. So BMP originally was really thought as a security kind of, protocol. So it's like, imagine that I have policies in place at my borders in BGP. Still, I would like to see, if my policies are rejecting something. So to get aware of root hijacks, flappings, and things like that. And so it was mainly thought as a hygiene kind of protocol, as a security protocol, so that you can monitor what is coming from the wild internet, right? And of course, that is, found a little bit limiting. Thinking in, it's preventing BMP to address a lot of use cases. So one good thing of this, 8 years at IETF, it's that, at least BMP has a very simple protocol design. The creativity going on at IETF, that is, great achievement to have something simple. And it was a great effort, but it's precisely as I was saying, right? So it's like things really changed over the years. So 2018, it's different than 2008. A lot of things happened. You have, hipsters coding fashionable languages and calling themselves DevOps. You have streaming pipelines, you have big data and things like that. So all of this is creating some sort of hunger for data that was not really there in 2008, and so BMP is not really able to catch up with that as it was standardized as for RFC 7854. So still to give you some background about BMP and BGP, so let's recap. So how would you monitor BGP? So I borrowed this slide from Randy Bosch from RIPE 74. So let's see if this advanced piece of technology works. Yes, it works. So let's say, so you have several peers in a, and you have a peering router, and then essentially when you are, collecting routes from this peering router, essentially you get only the best path, right? And what you do with BMP is that essentially from this peering router, you actually get all the paths, P0 to P4, right? And as I was saying, this is very similar to what you could potentially do with AddPath2, and we were doing with AddPath. But as I was saying, remember also the limits, the complications, and that comes with it. So Bgp Monitor, so BMP in practice, I extracted this from the RFC. So what kind of information you can expect to find in BMP? So I think the best way is to convey it with, the message types. So you have, let's say, two message types, which is initiation and termination, which is very inherent to the BMP session, so they are not carrying anything interesting. Then you have type 0 and type 6, which are about route monitoring and mirroring. I'm not aware of anybody having implemented route mirroring, but everybody implements route monitoring. So essentially you get the BGP messaging, right? So the peering router would, give you, all the BGP messaging, will deliver all the BGP messaging with his peers to the monitoring station. And let's say route monitoring, so monitoring versus mirroring should be about, mirroring, you are, really copying or replicating what you are receiving, versus route monitoring, it could be some sort of cooked format that it's being reconstructed and sent to you. Let's say this subtle philosophical thing, it's not something that implementers are caring about now, and they are focusing about route monitoring for the moment. And then, so you can find routes, and then you can find also peer up and peer down. So the peering router would tell you about, peers, his peers going up and down, so you can correlate routes to, events, right? And then you have statistics, and statistics is, how many routes are in the RIB. There is a lot of statistics that you can get out of it. So you can find, some routing events with your peers. You can find routing messaging, and you can find some statistics belonging to your network. So now let's come to the problem statement, which I already kind of anticipated so far. So the BGP, let's say, it's thanks also to BMP. BGP is one of the very few protocols that is attempting to have a clear monitoring plane, right? So think to other protocols. I mean, the clean monitoring plane, it's not there. I mean, for ages I tried to get, for example, in a clean and standardized way, information out of DNS. I mean, DNS caches and whatever. You don't have that monitoring plane. You have, non-standard solution. Every vendor or every producer of DNS software has a way to, let you extract that information. But still, as I was saying, with BMP only, focusing on edge ribbing, pre and post policies, you miss on a lot of use cases. So essentially, for example, if you are actually interested into getting the actual RIB, you still have to have BGP peerings. And if by any chance you want to see what you are advertising to people, so you are interested in to ads about, you still have to go with screen scraping, right? So theoretically, an operator like Entity today would have even 3 different methods in order to, get full BGP information: screen scraping, BMP, and BGP. So this is, the core of the problem statement. We would like to go to a nice, proper, standardized, method to get all of these vantage points. So to visualize it, let's say this problem statement, I mean, we can see this, so the ADRI being pre and post policies, like we have policies here, and this is what we get advertised from our peers. And we would like to add also lock rib, so we would like also to have visibility into this. We would like to have visibility into this and into that. So ADRI being ADRI about pre and post policies, right? So this is the very core of the discussion. And so this is borrowed, as you see, from a presentation we did at the ITF with Tim and Serpil from Cisco. And it was also a very interesting discussion over there because we were going that far, like we want to have that visibility. And for example, one interesting comment that we got from Rudiger from Dutch Telecom is that, you want to give me all of this visibility, and I know that there are policies and filters in between, so I would also like to know between pre and post policies why things are dropped. So can you give me codes? Can you give me reasons? So why something is being filtered out, for example? And so as a result of the problem statement, so I am involved with the team with Serpil and few other people in a couple of drafts at the ITF. So we have the draft ITF, GROW, BMP, ADRI bout, and the next one on the next slide will be the lock rib. So we are operating in the GROW working group. And, there has been quite some interest and quite some discussion so far. And, to tell you what are the use cases, a little bit that could be, addressed by extending BMP to lock rib and ADRI bout. So you have for the lock rib, of course, you can, monitor which routes are selected by the router. So imagine that you have the collection of ADRI being, then there will be some selection being made at the router, and the selection of the routers from all the ADRI bins will make it to the local rib, so to the rib that the user will use for forwarding, for routing, and things like that. And so with this, you can actually achieve the correlation with the NetFlow IPFix S-flow, so with flows with traffic, which is, something of very interest to me, but also monitor, the ECMP, so how many paths you have, and, you can have visibility into the backup paths and things like that. And of course, like, you can monitor also the locally originated, routes without needing, an actual BGP peering. And then you can do policy verification. And policy verification is something that you find also in ADRI bout, precisely because the good thing of having 5 different vantage points is that you can gain visibility into every stage of the route. So from how they are collected, how they are installed, and how they are propagated to other routers, right? And so also in ADRI bout, you can, let's say, monitor routes advertised to peers, right? So you can see what you are actually advertising to the other peers, which is very interesting for, I think it's a very good hygiene concept that, to know what you are advertising and monitoring that, but also the fact that, that is something at the core of many SDN solutions, right? If you think about people that want to balance, the ingress traffic, they break prefixes and things like that, and so now, there is SDN solutions for doing that. So having a proper and standardized way to achieve that instead of some black magics put together, it would be of very interest. And before going to the next slides, I recognize that I mentioned the keywords SDN and big data so far. I'm sorry to disappoint you that there will be no blockchain keyword as part of this presentation. Right? So both drafts, they are at their 0-1. 0-1 is after 0-0, and 0-0 is after the original proposal where the working group is adopting the draft. So there has been already a little bit of progress. And as part of the 0-1 draft at ITF, we have essentially a lot of text clarifications and essentially only minor changes like optional TLVs as part of the peer up and peer down messages, and those are mainly to, let's say, either reduce state or, for example, for Adj Reboot, there was quite some conversation on whether you should, do root monitoring, Adj Reboot for each peer or for each peer group, for example, if there are several peers that are in one peer group, whether, you should just do that or you should, monitor for every peer. And so with that minor, let's say, addition that we made to the 0-1 draft, essentially you can have this optional TLB in which you can specify what is, the peer group in case you want to do that kind of compression. And of course, the basis of IETF is, talking and, about things, right? And so if this whole topic is of interest to you, please review the, the drafts and, contribute. If you cannot come to, an ITF meeting, it's fine. A lot of discussion happens on the mailing list, so write on the mailing list and give us your opinion or give us your support. That is very important for progressing to the standardization, process. So, as I was saying, I'm concluding this presentation. So, as I was saying, this was about BMP, and you can collect BMP data with this software pmacct that I do develop. So, I wanted also to, speaking about pmacct, to tell you also how to contextualize, BMP data. So, what you can do with it actually. So yeah, pmacct is this, thing in the middle with the funny octopus face. And it's a free open source software. And as you see, there is a lot of, on the left side of this slide, a lot of data inputs, right? So you have streaming telemetry, you have lib pickup, so port mirroring, NetFlow, IPFix, SFlow, and you have also down here BGP, IGP, BMP, and many other things. And on the other side, you have a lot of, where you can store this information, right? So you have the, relational databases, NoSQL databases, flat file, message brokers like RabbitMQ and Kafka, and, memory tables. So with regards to BMP, what you can do, a very simple use case, or actually a collection of very simple use cases, is that you can, store NetFlow in flat files, or you can replicate SFlow, or you can send BMP on a Kafka broker, for example, right? But then you can do also something which is also more interesting, right? Which is you can start to, collect NetFlow and IPFix, right? You can replicate it to other, collectors for whatever reason. Maybe for security, you have, I don't know, Arbor, you have something like that. And then you can correlate this data with BGP, and now you think about, about the lock rib draft that I was talking about before, so that you can get visibility into the lock rib. So you could have BMP here instead of BGP, so you can start correlating NetFlow with the BGP data, or BMP data. And then you can aggregate it in a way in which essentially you enrich traffic data and you start to see the traffic per AES path, for example, right? Or the traffic, I don't know, per peer or per intermediate peer and things like that. Maybe because you want to see which traffic you are sending or you are receiving from some peers, and you are not peering with them, and you want to check, whether it makes sense to peer with them because you have substantial traffic with them. And so you can send this enriched, flow plus, routing data to flat files or to MySQL for reporting, flat files for just inspection, forensics, security, and things like that. And if you remember the previous slide, the BMP to Kafka, that will be still it, right? So what you can do is really do analytics on BMP or on BGP itself, and you can correlate it with flow traffic data, and then you can have this augmented kind of information. And the use case, since I mentioned a few times Kafka, essentially what is the use case for message brokers or for Kafka? It's essentially the fact that you can dump, augmented information, so BMP, BGP flows into Kafka, but that is only the standardized kind of interface for a number of column-oriented or document-oriented data stores like Elasticsearch, Influx, ClickHouse, all these names that I think you recognize, and that they bring a very nice setup, because then all of those are very tightly, coupled with visualization systems like Grafana, Kibana, or Superset, right? So you have a totally free, open stack. So this is all software that you can just download, and it's really, breaking the problem that you had with relational databases in the past, in which you dump your data into a relational database and then how to visualize it, right? Now, you have the ELK stack, so you have Elasticsearch that comes with Kibana, or you have InfluxDB that comes, with Grafana, or Druid with and ClickHouse with Superset. So it's very tightly integrated. It's very easy. You find a lot of containers. Oh, I mentioned containers. As well, on the internet, all available for free. So this is the time in which, if you have interest into data and in visualizing data, you have also all the tools, all the stack freely available to you and easy to use. So, and with that, I finish my presentation. Thank you very much, and hope it was of interest. Any questions?
Thank you. Thanks, Paolo. Any questions? Yes, please. Stand on the mic.
Alexander Shikov, Detail IX. As far as you may know, BERT software is used by a great number of internet exchange points. Did you have some kind of conversation with developers of BERT about BMP support in their software?
No.
They promised support in 2016, but still unsupported.
Yeah.
It's a bit confusing.
Yeah, so a general comment on that is that I really see that the adoption, implementation of BMP, it's very bumpy, right? So it's, so in the limited cases in which you have support, it's, there were bugs resolved over time, but also very incomplete implementations and things like that. So this is something that, I recognize. The standardization is much forward than the actual implementations. So,
thank you.
Yeah.
Thank you. Any other questions? Please be brave.
Or not. Let me go.
Okay. Anyway, interesting
Thanks.
topic. Thanks, Paolo. Okay, our next